Hello, this is John from Gadeon Corp. Today we're just going to go over how to create a data aggregator in Python, communicating with Excel. At least so I did it. There's multiple ways to do this. This one's actually pretty old. It's nice to be able to show these things because actually the reason I can show this one is because we're just not ended up using it. So I originally built this for our company, and as you'll see, all of the internal use tools are frankly not very pretty, but there's some reasons why I like writing it to Excel. You don't have to do that. You can do that in Python as well, and there are some pros and cons to doing either approach. The main pro of moving this all to Excel is that it's more user-friendly, at least absent of building a UI. So, because most people have a difficult time reading code, Excel just formats things as spreadsheets and graphs, and although you can do that in Python, it's still less accessible, at least for business people. So that was why I chose to write it to Excel. The other part of that was also because I hadn't at the time I wrote this, and this is actually relatively old now, probably about 6 to 7 months old now. So I probably wouldn't do everything the same way that I did, but one of the other reasons why I did it that way was because I had not yet written an interface between Python and Excel at the time, so I wanted to learn how to do that. So anyways, let's discuss this. There is one sheet that I can't show, I believe. Actually, I shouldn't be showing that either. Technically, actually, you guys probably shouldn't see any of that. Not that it really matters, to be honest, but the one sheet I can't show because it's got my API key on it, and that basically loads all the data, but it's pretty straightforward. So to kind of explain that, just like think of it as like pseudocode for a second, right? Basically, you're gonna import it. Well, I mean, we already have Pandas imported, but let's say like you want to import from YFinance, right, or Yahoo Finance. Typically, import YFinance as YF, and then if you wanted to import from Yahoo Finance, and you write something like whatever, let's just say like x equals like yf dot download, and then you put your ticker symbol, your start date and your end date, for example. So that's kind of how you write that. Now, obviously, Yahoo Finance doesn't require an API key, but something like the Fred does, right? So some of this data is obviously taken from Fred, some probably from the NASDAQ, right? I haven't looked at this in a while, to be honest, but just give you an idea. So the idea basically behind what we kind of did here, right, is if you have again, we'll just kind of write some pseudocode for the last sheet. We have, something like, tickers equals, and then you have a list of tickers, right? And then you switch this over to tickers, and, probably you have to write a for loop for that, for ticker and tickers. And then, you have this ticker, blah, 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 right? And then, something like, to a data frame, let's say new data frame equals PD for pandas dot data frame. Then what do we have here? Let's just make an is basically we're going to append the downloaded data to that. I just don't know what the best way to do that is right now. But anyways, you have some data frame, whatever, you set it up, append. Additionally, you could also write this as, if you have a new I just don't know how to like set that up the best way, so I'm just gonna leave it as is. Data frame.append x, or you can create new columns like so equals your data that you have up here. So that could be x close price, for example, is a common one if you're dealing with ETF securities. Anyways, blah, 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 blah. So the idea is that you create a list, right, of your ETFs, and then you write them as CSV files like I have here. And basically this list of CSV files is taken from the last file. So you can see that we take the macro data from various countries and some price and returns from ETF securities, right? So basically that's what we're concatenating in this program. We have a list, and then basically we're going to use the ExcelWriter. This is kind of key. You see this is from Pandas to write each of the CSV files to Excel. So basically we go through each of the CSV files in this list. And, you can write this kind of however you want. I mean, you could just put I, right? I don't know how familiar whoever's watching this is with Python. This isn't a tutorial, obviously, on, an introduction to Python, but, you can switch these out for whatever you want. So for each file in this list of files, we're going to read the file. So read CSV file, which is each of the items in the list. And then, we replace the CSV name to get the sheet name, and then we write it to Excel with dataframe.toExcel using the writer, and the sheet name is equal to the sheet name, and we do not index. Don't think it really matters if you index. In here, though, we have a date column, so it's completely unnecessary. Additionally, some of the dates are not aligned, so maybe that's another reason why we don't have index enabled. Anyways, and then obviously a printing error exception that prints out, and then just a message say yes, these are all saved to a CSV file. So, and the shortcut for that, by the way, is Shift Enter. In case you're wondering, actually a very useful set of shortcuts is knowing the different, how to switch between Jupyter notebooks, raw code, markdowns, and back to regular code using R for raw, Y for code, and M for markdown, where code is the only one that you see the changes up here, by the way. The code is the only one that doesn't seem to be intuitively obvious, right? M for markdown, R for raw, Y for code, whatever. Okay, so anyways, so we got our message, right? This all saved to the CSV files. Anyways, there's not really much to say there. It's pretty self-explanatory when you see the code. Okay, then in our other sheet, we have updating Excel. So the idea is that the data aggregator takes the Excel file, and not only can we write to it, we also write any new information to it. So basically, we go through the CSV file, we find the if there are any empty columns, we're going to drop them. And then we're going to look for the last non-empty column. We're going to make sure that it's not something that has appeared already in the file. And then we're going to add the new data to the Excel file, basically. So going through this, we load up our list again. So it's the same list of CSV files. We import pandas again. We go through each file in the CSV files, we read each file, and we set up an empty list called data for each column. So we go through each column in the data frames columns. We look for the any empty columns and drop the empty columns. And then if it's not empty, then we take the last value of the, for example, we have .ilocate. -1, so this is the last row in the list slash, I think this is a data frame. Yeah, the list of columns in the data frame. Okay, and then we append or add to the end of the empty list, and we add a dictionary to it. So to columns, we add column, and to the last non-NaN value, add the last value. Yeah, and then create a new data frame using the list of data. Once we have this list completed, we turn it into a data frame. Okay, cool. And then make a new file. Yeah, you can read that if you want. Okay, now we then go and map this to a new Excel file. So we basically set up a dictionary here with the curly brackets, going with the CSV to sheet. And so you can see here we have our key and then our item in each of the dictionaries. Not really going to go through that. That's basically just giving it new names. So then for the CSV file and the sheet name in the CSV to sheet dictionary, and then the items here, we are going to read each of the CSV files, and then with the ExcelWriter, we're going to write it to Excel, same way we did last time. Give us a updated, like, yes, this worked, and then otherwise an error if it didn't work. And so if I run this again, and we already, you know what, actually I'm not going to bother running it. We already know it works because we have the Excel files. So I'm not going to run this again. But anyway, so this is the code they use to basically update the Excel file. And then we have a dataframe.shape, which is just going to give you the dimensions of the data frame. So you see there's 67 rows and 2 columns in here. So anyways, that's all pretty straightforward. And to be honest, when I read this out, it probably sounds practically like plain English. And that's because that's pretty much what coding in Python is really like anyways. So now let's go over to our data. So in Excel, we basically end up with these about 15,000 dates per item. Not all of the items are on a monthly basis. So that's 15,000 months, by the way, of data. Now, some are obviously full, like the U.S. credit spread is full until we hit here, in which case it actually looks like the data starting in, when is it? When does it start? Okay, so I guess starting in 1970, we actually start getting daily data here. So actually, only the first 600 are literal months, and the rest are days. Okay, anyways, so that's all worth knowing, but this is just the raw data. Basically, the thing is, and that's just one, you can see that we flip through the sheets, right, to you know, find the other data. You can see what kind of data we actually pulled, right? So as you might find that interesting. Quick thing actually, because you'll see that this is not actually, I don't know why I'm doing it like that. You see that this one is like cell cuts off. We hit a, I'm not even talking as fast as I just did it, Alt-HOI, that reformats it to the width of the characters in that row, or sorry, column. So anyways, that's useful to know potentially for in terms of shortcuts. Yeah, but you can see all the data that we pulled. Now, I created a separate file where I filtered that out and gave it better formatting because I decided that would be easier before uploading it to the like dashboard. And again, I don't want to you know, be underwhelming with the presentation. This is just for internal use, or would have been for internal use, right? So I have, you know, frankly, no desire to make it pretty. Okay, but a few things that we have here that are kind of important for the design. And again, like there's other ways that you can do this, and I'd probably be able to make a better sheet at this point because this one's pretty old. But basically, the big thing to understand here is that we index in this new sheet, and per item, we're going to basically filter them out so that there's no spaces. And so what we have a function that says equals filter, and then I highlight the column for the data. So we take the entire column, and I'm not going to highlight this because sometimes it messes up. The big thing is, no, I'm highlighting now, is that we make sure that this is basically just not equal to a blank. So we take all cells in the column that are not blanks, and then with the change in absolute value, we just take the rate of change. So that's pretty straightforward. Or sorry, we do have a percent change and absolute change. It just depends on what the data is and what units it's in. Because for some of these, it's not going to make sense. Like the, inflation rate is already in a percent, right? So, I mean, taking a percent change of that probably isn't, doesn't make any sense. Now, another thing you'll see here too is that we have labels for whether the data is annual, daily, monthly, or quarterly. And those are just labels that are going to make it easier to bring together later. Okay, but that's pretty straightforward. Okay, anyways, the dashboard. Now, most of this is pretty straightforward. A lot of this you'll see actually is just, for example, the standard deviation function is just equals standard deviation dot, assuming it's population. Let me take our data. Right, that's very straightforward. The only difficult ones are to come up with a solution to, and, in fairness, one of the reasons why I had so much difficulty coming up with some of these was because I was trying to do it all as one function, which I decided later was just very difficult. It was not working. Now, you could still do that, but it's also not going to be very user-friendly. Now, so the solution that I basically came up with, and the issue that you'd have trying to deal with these for like collecting the last 3 months change, is that you need to account for the fact that the sheet can get updated, right? So how do you do that? Well, the answer that I basically settled on was taking the, if I first take the most recent, and actually I think that this is all from the other file, so like even though it highlights it here, it's not highlighting this file, so it's incorrect. Anyways, I believe what I did here is I took the most recent value first and then used that to index against the column and the row. And then this depends on whether or not it is like daily, monthly, quarterly, etc. Yeah. So basically to collect the most recent value, maybe I used, oh, sorry, no, I collected the row and column index first and then used that to find the most recent value. My bad. Okay, yeah, so we can see like this is pretty straightforward. It's equals count A function. We use XLOOKUP embedded in the count A function, and then we take our label that we're looking for and then go and find it in that data on the other sheet. And then this one too. Yeah. So because this is just for the column and these match, you don't have to go and find the column in the other sheet. Now, when you move over, so basically the idea is like, so for example, the fact that the S&P 500 index is in the second, the third column here, which I think I just indexed to 1 here, is it just lines up with the other sheet. So I'll just show you what I mean by that. Here is sorry, that's okay, yeah, so this is for the US, and you see that the S&P 500 is in the first effective column. Okay. Now, it's also worth noting too, so actually now that I'll just show you this, we obviously have the rate of change between each of these main labels. So on the next ones, we have to also like add an additional count. And so you can see that we basically just have a moving, like a cumulative sum that we add up in addition to the count above here. Yeah, so pretty straightforward. And then we can use that to find the last or the most recent value even after getting updated using the if index that we have here. Yeah, so you can take a look at that. Okay, and then now it's just really straightforward where we're like, just literally calculate the last 3 months change, last year change, and we just have to take off those values, or sorry, find the difference between the two values. So then it becomes very straightforward. But this is kind of the only set of tricks here, really. Once you figure out that, then the rest is still pretty straightforward, if you know what you're doing, at least. Yeah. Now you can also see that I did not bother finishing this because we just didn't even end up using this, which is also, I can show this. If we were using this, I can show this. Yeah, I wouldn't really say there's much else to that's very interesting about this, though. You can obviously make this more pretty by adding graphs if you'd like. I personally don't need them, but they're a nice visual. Okay, so actually another place too that you can look for inspiration on how to make things pretty, because if you're delivering this to clients or something of that effect, then you will want to make it look nicer, because I don't need graphs. A lot of people do, and it just makes it easier to understand trends, look at how things have changed over time, and it could still even be a little bit useful for me. My way of getting around that is just by looking at how it, the rate of change changes over time. Yeah, and I already know approximately how all these things look anyways, so doesn't really matter to me. But you can look at those AI videos of AI making Excel sheets look very pretty for some inspiration, and some of it's very cool actually. They use a lot of shapes, for example, and overlaying text and linking text over from there. They look very pretty. They, from what I understand, don't actually operate very well. Although I admire the colors, spelling mistakes and data errors are worse. So, but you can still go there for inspiration on how to make the sheets look nice or whatever. Okay, anyways, hopefully you found that interesting. We do have some other videos that we'll make in the future. I will probably make something on maybe either coding or fine-tuning language models. So that's something we're working, that we've already done, but we're working on it again. I'm not gonna say a full robo-advisor, because that would take a long time to go through, but maybe certain parts of how do we run a Monte Carlo in Python, and I will try to do some of that from scratch, but it would also make the video pretty long. And something on crypto valuations, I think, will also be in the near future. So anyways, hopefully you found that entertaining. You can like and subscribe. Yeah, bye.